Hello and welcome to Sudoku. In November of 2021, the website Logic Masters India hosted the World Sudoku and Puzzle Convention of 2021. And in round 4, there was this puzzle by Indian author Nityant Agarwal entitled Next to Nine Sum Sudoku, which is a rare variant of Sudoku, I think. And the rules are those, we have classic Sudoku rules, and whenever you see a number outside the grid, this is the sum of the digits that surround digit 9 in the corresponding column or row. For example, this 9 clue could mean that there is a 9 here, and two digits whose sum is 9 right next to the 9. With 90 points, this was one of the highest pointers in the corresponding fourth round and in the event overall. Although there were, points as high as 145, and I didn't have a look at those very difficult puzzles yet. This one I solved during the contest, so I may not struggle that much to solve it. All right, let's just see that there are 1, 2, 3, 4. I'm sure that was the intent of Nityant to have those as a visual theme somewhat. And no sum is really big. I mean, next to a 9, you could have 6 and 8 adding up to 14, but no total is more than 10. Is as high as 10. No, not, and there is 1, 2, 3, 4. So 1 can only be the sum of one digit of digit 9 only. So it means that in this column, 9 will have to be either here or there with a 1 next to it. And the same goes with 2. 2 will have to be either here or there. 9 will be either here or there with a 2 next to it, which means that we have a kind of X-wing on 9s here. Either they're on this big diagonal or on this one. And the same applies here, where we have 9 here or there, with either a 1 here and a 2 there, or 9 can be here, so we have 9 here and there, or 9 here and there. But then let's remember that 1 has to be in one of those two cells, 2 has to be in one of those two cells, but more importantly, 1 has to be either here or there, so we can't have a 1 in this cell. So we can't have 9 here, and this 9, therefore, must be at the other end of the row. And the same goes with 9 and 2 on this row. So this is a nice start. And then something can be done to disambiguate that. And it's by considering what happens with 3s and 4s. Namely, we now know that 9 can't be on the border here. So these 3 and 4 sum must be the sum of two digits. And 3 will be the sum 1 plus 2, 4 will be the sum 1 plus 3. So there must be a succession 1, 9, 3 somewhere, or 3, 9, 1 on this row. And let's consider the case where 9 is here. Let's imagine 9 is here, then we have a 1 here, and because of this, it implies that we must have 9 and 3 here, and obviously this doesn't work. 9 is repeated into this box. So this proves that 1 is on top, that the 9 and 1 here are on top, and 9 and 2 are at the bottom. And what else can be seen? Well, there must be a 2 here, there must be a 1 there, and that's interesting because 1 can't be here. Because of this, we must have 192 or 291 somewhere on this row, and 1 here wouldn't work. It would require 9 and 2 there. So 1 can't be here or there, so the last place is here. And there has to be a 1 somewhere here or there, but I think it's too early to determine. Let's have a look at where we can put those. So those successions must be somewhere here. And you see that 9 can't be here. It wouldn't be surrounded by 1 and 2. So 9 has to be in any of those 4 cells. And the same is true with 9 on this row. So let's explore the possibilities. What if I put 9 here with 1 and 2 there? Well, because of this, on this column, we also must have one such succession. And because 1 or 2 is here, 9 would have to be here or there, but both places are excluded by the digits that are already known. So 9 won't go there. Let's have a look at this. If we put 9 with 1 and 2 surrounding it, then we must have 9 somewhere there. Let's try 9 here. It must be surrounded by 1 and 3, so it will have to be 1 here and 3 there. And this puts an 8 here. But the most important aspect of this is that this seems to work. So let's recall that the situation with 9 here and 9 there seems to work. But I was wrong to delete all of this. I must still try 9 here, surrounded by 1 and 3. So this is a 2, this is a 1. And then, because of this 4, we must have a succession 1, 9, 3, or 3, 1, 9, 3, 9, 1. So 9 can't be here, 9 can't be here. So this one is impossible. So we must remember that 9 here and 9 there seems to be a possibility. Let's explore the next option. 9 here with 1 and 2, 1 can't go there. So that's a 2, that's a 1. And for this succession to be correct, we must have 1 on this side, 9 on this side. So it has to be 9 here, 3 there. Oh, sorry, that's the other way around. 3 here, 1 there. But then this 3 must be part of this 4. So we must have a 9 here, which doesn't work. So we can't put 9 into this cell. And the last option would be 9 with 1 and 2 here. Now, on this row, 9 and 1 must both be here, together with 3. So what are the options? It could be 9 here with 1, 3. But then it wouldn't work because of this 4. We would have 1 and 3 here, which obviously doesn't work. Or we could have a 9 here with 3 and 1. And there again, this one, because of this 4, would require a second 9 here, which would repeat. So that's a lot of options to study. But what is important here is that all options that didn't work broke almost instantly. So that's not a tedious exploration of cases. And that's the point. This takes some time, hence the somewhat high score, but no eliminations among them was that difficult. So we know that the only case we can consider is this one. And because of this one, we get 1 here, 3 there. This 4 is fulfilled. 2 here and 1 there. This 3 is fulfilled. A 6 here to fulfill this 9. Oh. Well, actually, that doesn't seem to work either. Oh, I did something wrong, sorry. 3 and 1 are the other way around. And 1 and 2 for this 3, and 8 here for this 9. And I think this time it's good, yes. This one it works. This time it works. Now let's have a look at this 3 and this 4. Or perhaps I should mention this 7. This 7 must be surrounded by 2 digits whose sum is 7. It won't be 1 and 6. It can still be 3 plus 5 or 3 plus 6. But there's a 2 here, so the options, 3 plus 4, sorry. The options are those. And I pay attention to the, I synchronize, like I like to say, I synchronize digits here. And another point of interest is this 9. Well, the digit 9 in this column will be here or there. And it will be surrounded by digits that don't include a 1 or a 3. So they will be either 2 plus 7 or 4 plus 5. Right. And let's have a look at those. We know that somewhere here the possible positions for 9 are here and there. So in this box, 9 will be either here or there. And we know that there can't be a 1 here because of this 1. So the corresponding 1 will have to be there. So let's just see that there must be a 9 and a 1 here, or a 9 and a 1 there. And the 9 corresponding to this 3 will have to be 1, 9, 2, for example. That's an option. Or here, 1, 9, and 3. And in both cases, the 1 that's not here will have to be in this box. And the 9 that's not here will have to be in this box. So they must cross the border. This means that the 9 in this box can't be here because it would have to use a 1 in this box that is not this one. So the 9 must be next to the border and the corresponding 1 must be here. And they come with a 2 or a 3 there. And that tells us that the 9 here must be in the middle of the box. And the interesting part is that this 7 doesn't use a 1, so it must be either 2 plus 5 or 3 plus 4. And something very interesting there is that either of those cases here eliminate the possibility to have 4 plus 5 here. Here we get either 2 plus 5, so 4 plus 5 is not possible here, or we get 3 plus 4 here, in which case 5 plus 4 is not possible here, so this here must be 2 plus 7. And this shows that the 7 here can't use the 2, so this one must be 3 plus 4. And this is massive, as Simon would say, because 3 is no longer a possibility here, so we know that the right-hand scenario is the correct one. So this is 1, 9, and 3, and this one tells us that this pencil mark is the correct one. So this is the first impact, and some of those now have been fulfilled. And the second impact is that this by value shows us that the decomposition of 7 in this column can't be 3 plus 4. Otherwise, we wouldn't have a choice for a digit to put into this cell. So this must be 2 plus 5. And this 7th clue is fulfilled. By Sudoku, we get a 2 down there. Now let's ponder what we're left with. This 7 sum can't use a 1 or a 2, so it must be 3 plus 4. This is fulfilled. This 7th clue must be 1 plus 6. This one is fulfilled. And we're left with this 9. We must have 2 digits with a sum of 9. It can't be 1 plus 8. It can't be 6 plus 3. It can't be 2 plus 7. So it has to be 4 plus 5. And there's a 5 here. This one is fulfilled. And this 9 now can't be 1 plus 8. It can't be 2 plus 7 because there are too many 2's. And actually, by Sudoku, we get a 2 here, 7 here, and a 2 there. And by Sudoku, still we get a 3 here, and a 7, 8 pair into those cells. So let's get back to this 9. We can't use the 1, the 2. It can't be 4 plus 5. It has to be 3 plus 6, and there's a 3 here. So we get 6 here, 3 there. This is fulfilled, and now the rest should be standard Sudoku. So this 3 eliminates this 4 and this 3. Here we must have a 5 and a 6. This column still needs 7, 8, and a 3. So we get a 3 here, 7 or 8 there. This needs 6, 7, and 8. Because of this 6, we get 7 or 8 here, and only 4 can go there. Next, there's a 1 here. 6 goes there. 5 and 8 because of this 5, and this now is a 4. 2, 2, 2, there's a 2 here. Because of 3's, we get a 3 there. This 3 fixes the 3, 4 pair. And this is a 7, 8 pair. Those two must have a 4 and a 6. There's a 4 here. This now must be a 6, 7 pair. This 4 goes into this cell, and it gives a 5, which resolves the 5, 6 pair on top of the grid. This is a 3, 7 pair. There's a 3 here. This is a 7, 8 pair. We're getting there. There's still some work to be done. This column needs a 5. There's a 5 here. And the remaining digit is an 8. Those are 6 and 8. There's an 8 here. This 8 fixes the rest of those columns. And we get a 5. A 4, sorry, then a 5, a 6, and I think the remaining digits won't need that many explanations. Right, this is there, there, and the last digits are here an 8, a 5, and a 6. And that's all for this very nice puzzle by Nityant Agarwal. And thank you for watching this video. And see you soon on Sudoku.